On November 5th, the Virtual Telescope Project released two new images of the interstellar object known as 3I-ATLS, and what they revealed has left the scientific community more unsettled than ever before. The images show Atlas as a compact, almost pristine source of light, without the faintest trace of the glowing cometary that should surround a body of its size and trajectory. Even more baffling, its appearance has barely changed since the Hubble Space Telescope captured it months earlier in July 2025. For an object that should have shed billions of tons of material by now, the absence of any visible debris is nothing short of inexplicable. To put this into perspective, astrophysicists estimate that Atlas should have lost at least 13% of its total mass, more than 5 billion tons of matter, during its approach to the Sun. That kind of mass loss would normally create a spectacular halo of gas and dust, a glowing tail stretching across the sky. Yet, in the case of Atlas, there is nothing. No tail, no haze, no evidence of the violent outgassing that defines comets. Instead, Atlas remains eerily clean, a silent traveler that refuses to behave like anything we've ever seen before. For comparison, astronomers point to Comet Lemon, a relatively ordinary comet in our solar system. When Lemon nears the Sun, it behaves exactly as expected. Solar radiation pressure pushes gas and dust outward, forming a bright, transparent tail that points away from the Sun. It's a textbook example of cometary physics. Atlas, however, defies that textbook. It shows no tail, no plume, no visible signs of mass loss, and yet somehow it is accelerating, drifting off its predicted orbit in ways that cannot be explained by gravity alone. Harvard astrophysicist Avi Loeb has been one of the most vocal scientists analyzing this enigma. According to his calculations, the absence of a visible gas cloud is not just puzzling, it's damning. If Atlas were truly accelerating due to outgassing, the amount of material required would be so immense that it would create a blindingly obvious glow, visible even to amateur telescopes. The fact that no such glow exists suggests that something else, something unknown, is at work. The mystery deepened on October 29th when Atlas reached its closest point to the Sun. At that moment, it suddenly accelerated in a way that defied all normal gravitational laws. NASA's Jet Propulsion Laboratory reported that Atlas's actual position had deviated from its predicted orbit by 4 arcseconds. To the untrained eye, that number may seem trivial, but at a distance of 203 million kilometers from the Sun, such a deviation translates into a staggering error, tens of thousands of kilometers off course. For scientists who pride themselves on the precision of orbital mechanics, this was a shock. The data revealed that Atlas was accelerating at a rate of 0.2 millimeters per second squared. That may sound minuscule, but over the course of a month, it pushed Atlas more than 80 kilometers off its expected path. Even more unsettling, the acceleration wasn't in a single direction. Instead, it had 2 distinct components: an outward push away from the Sun and a sideways drift. In other words, Atlas wasn't just being nudged, it was being steered. NASA was quick to reassure the public that Atlas posed no threat to Earth. Its lopsided orbit, while strange, would not bring it anywhere near our planet. The only potential close encounter on the horizon was with Jupiter in March 2026, a date astronomers are now watching with intense interest. But the real question remained: what was causing Atlas to accelerate? To explain this to the public, scientists used a simple analogy. Imagine throwing a ball into the air. Gravity pulls it along a perfectly predictable curve. But if tiny motors were attached to the ball, firing bursts of thrust at irregular intervals, its trajectory would suddenly shift. That's exactly what seems to be happening with Atlas. It is no longer obeying the rules of pure gravity. Something else is acting on it. The most common explanation for such behavior in comets is outgassing. As ice on the surface melts under the sun's heat, it turns into vapor and jets outward, like miniature rocket engines. This process can nudge a comet off course. But in Atlas's case, the numbers don't add up. The amount of gas required to produce the observed acceleration is absurdly large, far beyond what any known comet could release. And yet, the telescopes see nothing. No jets, no haze, no evidence of the violent outgassing that defines comets. Instead, Atlas remains eerily clean, a silent traveler that refuses to behave like anything we've ever seen before. This is where Avi Loeb's calculations become critical. By combining Atlas's estimated mass with its observed acceleration, he deduced how much gas would need to be expelled to account for the thrust. The result was staggering. Atlas weighs at least 33 billion tons, making it vastly larger than the first two interstellar objects ever discovered, Oumuamua and Borisov. To generate the observed acceleration through natural outgassing, Atlas would have to lose at least 1/6 of its mass in a single month, 5 billion tons of gas. Such a release would create a massive, blindingly obvious glow, impossible to miss. And yet, no such glow exists. This contradiction has set the stage for one of the most dramatic scientific showdowns in recent memory. From late November 2025 through January 2026, dozens of ground-based telescopes, along with the Hubble and James Webb telescopes, will be trained on Atlas. On December 19th, it will make its closest approach to Earth, passing at a distance of 160 million miles. If the gas cloud exists, we will see it. If it doesn't, the natural explanation collapses, and scientists will be forced to consider alternatives that border on the unthinkable. There is precedent for this kind of mystery. Oumuamua, the first interstellar objects ever detected, also exhibited unexplained acceleration without any visible outgassing. Despite the scrutiny of the Spitzer telescope, no signs of gas were ever found. In the end, researchers were forced to label it a dark comet, a paradoxical term, since the defining feature of a comet is its outgassing. Atlas, however, is even stranger. Not only is it accelerating without a tail, but it also exhibits anomalies in brightness and color that defy natural explanation.
As Atlas approached the Sun, it brightened at a rate of magnitude -7, far faster than any comet on record. Typical comets brighten in the range of -2 to -3. Atlas's increase was more than double that, an unprecedented phenomenon. Even more bizarre was its color. Instead of glowing red, as cold surfaces normally do, Atlas appeared blue, bluer than the Sun itself. This is profoundly strange. Natural dust tends to redden light, not shift it toward blue, and the surface of Atlas, being far colder than the Sun, should glow red, not blue. The only natural explanation offered so far is the emission of ionized gases like carbon dioxide, but even that fails to fully account for the intensity of the blue hue. At this point, the debate is shifted from the purely scientific to the philosophical. The question is no longer just what is Atlas, but what do we do when the data doesn't fit any existing theory? Some scientists argue that the data must be wrong, that the instruments are misreading. But Avi Loeb counters that dismissing data simply because it doesn't fit theory is bad science. The role of science, he insists, is to follow the evidence, no matter how uncomfortable the conclusions may be. And so, the countdown to December 19 has taken on an almost apocalyptic tone. If Atlas reveals the expected gas cloud, the mystery will be solved, and it will be classified as an unusually massive but natural comet. But if no cloud appears, the implications are staggering. It would mean that Atlas is being accelerated by some other mechanism, perhaps even a technological one. The possibility that we are observing an interstellar probe launched by an ancient civilization is no longer confined to science fiction. It is a hypothesis that must be taken seriously. The deeper astronomers looked, the stranger Atlas became. What began as a single unexplained acceleration soon unfolded into a catalog of anomalies so bizarre that each one seemed to challenge the very foundations of physics. Researchers began compiling them, and the list grew longer and longer, until Atlas was no longer just a comet, it was a puzzle box of contradictions. 9 anomalies stood out, each one demanding explanation, each one refusing to fit the mold of natural celestial behavior. The first anomaly was its orbit, nicknamed the impossible path. Atlas travels on an orbit tilted just 5 degrees to the ecliptic plane, the flat disk in which all planets circle the sun. For an interstellar object arriving from deep space, this is almost impossible. Such bodies should approach from random directions, cutting across the solar system at odd angles. Yet Atlas's trajectory is nearly parallel to the planetary plane, as if it had been deliberately aligned. The odds of this happening by chance are vanishingly small, astronomers say, equivalent to hitting a bullseye in the dark. Some whisper that this precision hints at purposeful navigation, not random drift. The second anomaly was even more shocking, the physics-defying jet. In July and August 2025, Atlas unexpectedly produced a jet of material that shot straight toward the sun. This is the exact opposite of what comets do. Normally, solar radiation pressure pushes material away from the sun, forming tails that stream outward into space. Atlas's jet, however, pointed inward, as though it were resisting the sun's force. To scientists, this was like watching someone run with their hair flying forward. It broke the most basic rules of cometary physics. Plasma physicists speculated that Atlas might possess an artificial magnetic field, or even a propulsion mechanism akin to ion thrusters, technology humans have only tested on small spacecraft. The third anomaly was its sheer size and speed. Atlas is 1,000,000 times more massive than Oumuamua and 1,000 times more massive than Borisov, yet it moves faster. In astrophysics, larger objects tend to move more slowly, bound by the gravity of their parent star systems. Atlas defies this rule completely. Its velocity is paradoxical, as if it were powered by something beyond gravity. Some theorists suggested antimatter propulsion or directed photon energy, concepts that exist only in advanced theoretical models. If Atlas truly harnesses such mechanisms, it would represent technology far beyond human capability. The fourth anomaly was its timing. As Atlas passed through the inner solar system, it coincidentally skimmed past Mars, Venus, and Jupiter, but avoided Earth during perihelion, the moment when it should have been brightest and easiest to observe. This avoidance was so precise that it raised eyebrows across the scientific community. Was it mere coincidence, or did Atlas deliberately steer clear of Earth? The odds of such timing are rarer than winning the lottery. Some researchers began to suspect that Atlas was not just moving randomly, but following a pre-calculated route, like a probe choosing flybys to collect data from major planets while avoiding direct contact with humanity. The fifth anomaly reinforced that suspicion. Spectroscopic analysis revealed that Atlas contained more nickel than iron, a ratio common in man-made alloys. Natural comets typically have a chaotic mix of metals and minerals. Atlas's finely tuned metallic composition seemed purposeful, almost engineered. Some scientists compared it to alloys used in jet engines and spacecraft, materials designed to withstand extreme heat. This raised the unsettling possibility that Atlas was not a natural body at all, but the remnant of an ancient technological structure, perhaps the shell of an ancient spacecraft drifting through interstellar space. The sixth anomaly was its dryness. Comets are often described as dirty snowballs, with 80 to 90% of their mass composed of water ice. Atlas, however, contained only 4% water, drier than the harshest deserts on Earth.
Infrared spectral analysis found no signs of water vapor even as Atlas approached the Sun. Some scientists suggested that its surface might be coated in a refractory ceramic or composite layer, preventing evaporation. If true, this would imply Atlas possesses an artificial shell, a feature never before seen in any natural comet. Its dryness, combined with its metallic composition, made it look less like a comet and more like a machine.
The eighth anomaly connected Atlas to one of the greatest mysteries in astronomy, the WOW signal of 1977. Both Atlas and the WOW signal originated from nearly the same cosmic coordinates, in the constellation Sagittarius. The probability of this coincidence is extremely low, yet too precise to ignore. Some SETI researchers propose that Atlas might be related to the origin of that signal, or even serve as a relay station transmitting signals across decades. The polarization pattern of its light, similar to reflections from flat metallic surfaces, only deepened the intrigue. Could Atlas be part of a communication network, silently operating in cycles beyond human comprehension? The ninth anomaly was perhaps the most unsettling of all. Atlas appeared hotter than the Sun. Its brilliant blue hue suggested it was emitting energy at temperatures exceeding 5,800 Kelvin, the surface temperature of the Sun itself. For a non-stellar object, this is impossible. No natural comet, asteroid, or planet can reach such energy levels. The only plausible explanation would be advanced technology, some form of energy emission unknown to humanity. To astronomers, this was the final straw. Atlas was no longer just a comet behaving strangely. It was something else entirely. Taken together, these 9 anomalies painted a picture that was difficult to dismiss. Atlas's orbit was too precise, its jets too unnatural, its composition too engineered, its dryness too extreme, its light too polarized, its timing too suspicious, its heat too impossible. And looming over it all was the eerie coincidence with the WOW signal, a mystery that has haunted astronomers for nearly half a century. The conclusion was unavoidable. Atlas was unlike any object ever recorded in the solar system. Whether it was a natural body with unprecedented properties or the remnant of interstellar technology, it demanded explanation. As December 19th approached, anticipation grew. Hundreds of telescopes, both ground-based and orbital, prepared to capture every detail of Atlas's close pass. Scientists hoped to finally answer the question: was Atlas a comet, or was it something far more extraordinary? If the expected gas cloud appeared, the mystery would be solved. If not, the debate would escalate into uncharted territory. For the first time in history, humanity might be witnessing direct evidence of technology not of this Earth. As the anomalies piled up, the scientific debate began to spill beyond the walls of observatories and into the public imagination. Atlas was no longer just a comet. It had become a symbol of something larger, something that challenged humanity's place in the universe. Each new observation seemed to push the boundaries of what was possible, and each unanswered question fueled speculation that bordered on the extraordinary. Some researchers began to whisper about the possibility of interstellar technology. If Atlas was not behaving like a natural comet, then perhaps it was not a comet at all. Perhaps it was a probe, launched millions of years ago by a civilization far older than ours. The idea was staggering, but the evidence was difficult to ignore. Its precise orbit, its physics-defying jets, its engineered composition, all of these pointed to something beyond chance. Could Atlas be an ancient machine, silently carrying out a mission across the stars? The timing of its arrival deepened the mystery. Atlas had passed close to Mars, Venus, and Jupiter, but avoided Earth during its brightest moment. To some, this looked less like coincidence and more like strategy. A probe designed to study planetary systems might deliberately choose flybys of major planets, gathering data on their gravitational fields, atmospheres, and magnetic signatures. Avoiding Earth could be intentional, a way of observing humanity from a distance without direct contact. The thought was unsettling. What if Atlas was watching us, recording our progress, silently assessing our civilization? The composition of Atlas added fuel to this fire. Spectroscopic analysis revealed a metallic ratio more common in man-made alloys than in natural bodies. Nickel outweighing iron, dryness beyond any desert, and a possible ceramic shell, all of these suggested construction, not random formation.
Some scientists speculated that Atlas might be the remnant of a destroyed spacecraft, its outer shell drifting through space long after its creators were gone. Others proposed that it was still functional, a probe designed to withstand the harshest conditions of interstellar travel. Then came the connection to the WOW signal. In 1977, radio astronomers detected a mysterious burst of energy from the constellation Sagittarius, a signal so unusual that one researcher famously wrote "wow" in the margins of the datasheet. For decades, the signal remained unexplained. Now, Atlas was arriving from the same region of space, its polarization pattern eerily similar to reflections from metallic surfaces. The coincidence was too precise to dismiss. Could Atlas be related to the WOW signal? Could it be a relay station, transmitting signals across the galaxy on cycles that spanned decades? The possibility was electrifying. The idea of Atlas as a communication device raised profound questions. If it was transmitting signals, who were they for? Were they meant for us or for another civilization? Was Atlas a messenger, a probe, or a silent observer? Some theorists suggested that it might be part of a network, a chain of devices scattered across interstellar space, each one relaying information back to its origin. If so, then Atlas was not alone. It was part of something larger, a system designed to span the stars. The implications were staggering. If Atlas was truly artificial, then humanity was not the first technological civilization in the galaxy. Others had come before us, capable of building machines that could survive for millions of years, crossing the void between stars. The thought was both exhilarating and terrifying. Exhilarating because it meant we were not alone. Terrifying because it meant we were being watched. Some scientists began to speculate about the purpose of such observation. One theory, spreading through underground forums, was called the mirror galaxy effect. According to this idea, every time a civilization reaches a certain threshold, nuclear power, spaceflight, or advanced energy, an observation device is activated from interstellar space. Its purpose is to assess the threat level of that civilization to determine whether it poses a danger to others. Atlas, in this view, was a silent gatekeeper, watching humanity as we crossed the threshold of nuclear power and space exploration. The thought was chilling. What if we were being judged? Others proposed more benign explanations. Perhaps Atlas was simply a probe, gathering data on planetary systems, mapping gravitational fields and recording electromagnetic signatures. Perhaps it was part of a millennium-long exploration plan, launched by a civilization that sought to understand the galaxy. In this view, Atlas was not a threat, but a messenger, a silent witness to the unfolding story of the universe.
Yet the anomalies refused to be ignored. Its blue hue, hotter than the sun, suggested energy emission beyond natural limits. Its polarization pattern hinted at reflective panels or geometric structures. Its dryness and metallic composition pointed to engineering. Its orbit and timing suggested navigation. Each anomaly was a piece of a puzzle, and together they formed a picture that was difficult to dismiss. Atlas was not behaving like a comet. It was behaving like a machine. As December 19th approached, anticipation reached a fever pitch. Telescopes around the world prepared to capture every detail of Atlas's close pass. Scientists debated furiously, some insisting that it must be natural, others arguing that the evidence pointed to technology. The public watched with fascination, drawn into the mystery by headlines and speculation. For many, Atlas had become more than a comet. It had become a symbol of humanity's search for meaning in the cosmos. The stakes could not be higher. If Atlas revealed the expected gas cloud, the mystery would be solved, and it would be classified as a comet with unusual properties. But if no cloud appeared, the natural explanation would collapse, and the possibility of interstellar technology would have to be taken seriously. The thought was staggering. Humanity might be witnessing the first confirmed evidence of intelligence beyond Earth. And so, the countdown continued. Each day brought us closer to the moment of truth. Each observation added to the mystery. Each anomaly deepened the debate. Atlas was no longer just a comet. It was a question, a challenge, a mirror held up to humanity. Was it natural, or was it artificial? Was it a messenger, a probe, or a silent gatekeeper?
The answer remained elusive, but the implications were profound. For the first time in history, we stood on the brink of discovery, staring into the void and wondering if something was staring back. As the days ticked down toward December 19th, the atmosphere among astronomers and enthusiasts alike grew electric. Atlas was no longer just a curiosity. It had become a test of science itself. If the expected gas cloud appeared, the mystery would dissolve into the realm of natural physics. But if it did not, the implications would ripple far beyond astronomy, forcing humanity to confront the possibility that we were observing technology not of this Earth. The countdown was framed as historic. Telescopes across the globe, from small amateur setups to the most advanced orbital observatories, were trained on Atlas. Every photon of light it emitted was precious, every spectral reading a potential clue. Scientists spoke of the moment with reverence, calling it a turning point in human history. For the first time, we were not just looking at the sky. We were waiting to see if the sky would look back. The stakes were clear. Physics demands that acceleration requires mass loss. If Atlas truly accelerated at the rate observed, then billions of tons of gas must have been expelled. Without that gas cloud, the cometary explanation collapses. And when theory collapses, something else must rise. That something else could be the most profound discovery humanity has ever made: direct evidence of interstellar technology. The speculation grew bolder. Some theorists suggested that Atlas might be powered by antimatter propulsion, a technology that only exists in theoretical models, but could explain its paradoxical speed. Others proposed directed photon energy, beams of light harnessed to push it across the void. Plasma physicists pointed to its inward jet, speculating about artificial magnetic fields or ion propulsion mechanisms. Each hypothesis carried the same implication. Atlas was not a natural body. It was a machine. The timing of its trajectory added to the unease. Passing close to Mars, Venus, and Jupiter, but avoiding Earth, seemed too precise to be random. Some astronomers began to suspect that Atlas was deliberately mapping the solar system, recording gravitational and electromagnetic fields, perhaps even scanning for signs of life. The thought was unsettling. What if we were not the observers, but the observed? Underground forums buzzed with theories. The mirror galaxy effect gained traction, suggesting that every time a civilization reaches the nuclear threshold, an observation device is activated from interstellar space to assess its threat level. Atlas, in this view, was a silent gatekeeper, watching humanity as we crossed into the atomic age. Others speculated that it was part of a millennia-long exploration plan, launched by a civilization that sought to understand the galaxy. In either case, the conclusion was the same. Atlas was not random. It was purposeful. The anomalies reinforced this narrative. Its metallic composition resembled engineered alloys. Its dryness suggested a protective shell. Its polarization pattern hinted at reflective panels. Its blue hue implied energy emission beyond natural limits. And its connection to the WOW signal tied it to one of the greatest mysteries in astronomy. Each anomaly was a piece of evidence, and together they formed a picture that was difficult to dismiss. Atlas was not behaving like a comet. It was behaving like a probe. As December 19th approached, anticipation reached a fever pitch. News outlets covered the story with breathless headlines. Social media buzzed with speculation. Amateur astronomers prepared their telescopes, eager to capture their own images of the enigmatic visitor. For many, Atlas had become more than a scientific mystery. It had become a symbol of humanity's search for meaning in the cosmos.
The implications were staggering. If Atlas was truly artificial, then humanity was not alone. Other civilizations had come before us, capable of building machines that could survive for millions of years, crossing the void between stars. The thought was exhilarating, but also terrifying. Exhilarating because it meant we were part of a larger cosmic story. Terrifying because it meant we were being watched, perhaps judged by intelligences far beyond our understanding. Some scientists urged caution. They reminded the public that extraordinary claims require extraordinary evidence. Atlas might yet reveal a natural explanation, one that we simply had not considered. But others argued that the evidence was already overwhelming. The anomalies were too numerous, too precise, too consistent. Atlas was not a comet, it was something else. And so the world waited. December 19 became a date etched into calendars, a moment of collective anticipation. Telescopes prepared to capture every detail, scientists prepared to analyze every photon. The public prepared to witness history. Would Atlas reveal the expected gas cloud, proving it to be a comet? Or would it remain clean, silent, and inexplicable, forcing us to confront the possibility that we were observing interstellar technology? The answer remained elusive, but the implications were profound. Atlas was no longer just a comet. It was a question, a challenge, a mirror held up to humanity. Was it natural or was it artificial? Was it a messenger, a probe, or a silent gatekeeper? The answer would shape our understanding of the universe and our place within it. The scariest thought was not what we saw, but what we did not. Atlas had revealed anomalies, but it had also concealed its true nature. Some scientists speculated that it might possess communication mechanisms operating in frequency bands beyond human detection. Others suggested that it was scanning the solar system on a set schedule, searching for life or testing human technological progress. The thought was chilling. What if Atlas was not just passing through, but actively studying us? More daring predictions suggested that on December 19, Atlas might emit a synchronization signal, not for us, but for somewhere else. Perhaps it was confirmation that Earth had been discovered. Perhaps it was part of a millennia-long exploration plan. Perhaps it was a message to another civilization, transmitted across the stars. The possibilities were endless, and the implications were profound. As the countdown continued, humanity found itself staring into the void, wondering if something was staring back. Atlas was silent, hurtling through space at an inexplicable rate of acceleration. But if the theory of interstellar technology was correct, then we were not just observing a distant celestial body. We were being observed. We were the subjects of research. And perhaps, for the first time in history, we were about to realize that we were not alone. December 19 loomed as a turning point. If Atlas revealed the expected gas cloud, the mystery would dissolve into natural physics. But if it did not, the implications would be staggering. Humanity would be forced to confront the possibility that we were witnessing technology from another civilization. The thought was both exhilarating and terrifying. Exhilarating because it meant we were part of a larger cosmic story. Terrifying because it meant we were being watched. And so the world waited. Telescopes prepared. Scientists debated. The public speculated. Atlas hurtled closer, silent and enigmatic. The countdown continued. The moment of truth approached, and humanity stood on the brink of discovery, staring into the void and wondering if something was staring back.